Swayam Prabha. Digital India. Educated India.
We found that there are about 54 lakh kilometers or 5.4 million kilometers of roads in the country. The national highways contribute only to 1.2 lakh kilometers, less than 2% of the country's road network, but carries nearly 40% of the traffic. Majority of the roads in the country are rural roads, low volume roads. So the challenge before us is whether to invest the money to provide a connectivity to a low volume roads connecting the villages, or use the money for national highways. So when you want to decide these roads, as I was mentioning in the last class, the major problem that we face is non-availability of materials for construction in the country today. So there are different choices for you to construct the payments. The one is a flexible payments or a bituminous payment. Second is a concrete payment or a rigid payment. Third is a composite payment. I'll take you over what are these types. What is the load carrying mechanism and how they are effective in constructing a sustainable road infrastructure in the country. The issue at this point of time is that I can spend less initially, but spend more on maintenance later, vis-a-vis spending more initially and spending less on maintenance subsequently. So which is the lowest in terms of life cycle cost? So life cycle is a parameter that we consider for a period of 20 years, 25 years, 30 years. Which of those roadway component or a type of payment will result in the lowest life cycle cost is something that we need to talk about. What we saw in the last class was that conventionally a bituminous payment will consist of different layers. It can be in filling or it can be in cutting. It has got an embankment on which the entire load is to be carried. Subgrade is the lowest layer, which consists of soil. Normally for a national highways, the thickness of the subgrade is around 500 millimeters. For rural roads, it is around 300 millimeters. So this is the layer, soil layer system which supports the entire load that coming on the pavement. What you are seeing on the top is only the black top, but what has been buried below is the bituminous black top, a base course, a sub base course, and a subgrade. So out of this, the bituminous layer thickness is less, maybe around 150 millimeter, 200 millimeter, but that will cost nearly 40% of the total pavement layer cost. So if you want to reduce the material consumption, then what are the options before us? So the thickness of the pavement layers, what it means, what you see here are the sub base, base course, binder course, and a bearing course. That depends upon the strength of the subgrade soil. If subgrade is weak, traffic is high, then thickness of the pavement layer is large. If the subgrade is strong, then the thickness of the pavement can be reduced significantly. As can be seen in the last class, we saw that if the subgrade strength is, for example, 5% is the strength of subgrade quantified in terms of CBR, which is the California bearing ratio. So that is a parameter that we consider for the design of the pavement. If subgrade CBR is 5%, the traffic is around 150 million standard axles. The thickness of the pavement is of the order of around 77 centimeters. If the subgrade strength is not 5, it is 4, 3, 2, then thickness will go up to even 1000 millimeters. So weaker the subgrade, higher the traffic, thicker is the pavement. Out of this, the bituminous layer is around maybe 220 millimeters. We have got 250 millimeters of a granular layer and about a subbase layer of 300 millimeters. So how do I reduce the material consumption is the first challenge before you when you graduate. So how much material do we require for constructing these roads? For construction of a typical 60 kilometer of a road stretch, I require about 20 to 30 lakh tons of good aggregates. I'll come to the issue of sustainability in due course. But remember, for constructing 1 kilometer of a 2-lane road, I require nearly 15,020 metric tons of aggregates. Now, when you have 1,20,000 kilometers of national highways, you can compute how much material do we require when you convert a single lane into a 2-lane, 2-lane into a 4-lane, or a 6-lane or 8-lane. Huge quantity of materials are required, but we don't have good quality aggregates. So how do we construct sustainable long-lasting payments is the first challenge. So here again comes, I can go in for a concrete payment. So in the case of a bituminous payment, the road is taken up by all the pavement layers. So I require a thicker layer if you want to distribute the load to the subgrade level so that pavement does not fail prematurely. Alternatively, I can go in for a concrete pavement. The concrete pavement take up the load by the slab action. That as can be seen here, that it consists of different layers again. The concrete pavement takes up the load by a slab action. So even if the weak subgrade is weak, I can provide a ready layer and reduce the thickness of the pavement layers. So I need only one layer of concrete, maybe over a base course. So total thickness of the pavement is much lesser. This concrete pavement will last for 30 years without major maintenance, but initial cost is higher than a conventional bituminous pavement. So as I was mentioning earlier, should you spend more initially and spend less subsequently, or spend less initially but spend more subsequently? But as it can be seen, the quantity of material required in a bituminous pavement is huge. The quantity of material required for a concrete pavement is less. So one way of reducing the aggregate consumption is by considering alternate materials in the construction like a concrete pavement, where the load is taken up by the slab action. So as I was mentioning, we require about 150 million cubic meter of aggregates every year. If you go to Northeast, you will not get a good quality aggregates at all for road construction. If you go to Andaman Nicobar Islands, all the aggregates in Andaman Nicobar will absorb the moisture. The water absorption may be more than 2%, we permit up to 2%. If it absorbs more water, it will lose its load carrying capacity. If it is used for bituminous construction, the binder will strip off from the aggregates. So you will find potholes, cracks and rutting failures. So if we require about 150 million cubic meter of aggregates, one hand. Other hand, if you look at states like West Bengal, where aggregates are not available, you have to transport the aggregates from Bihar. If you want to transport the aggregates for over 60 kilometers, about 20 lakh tons of material, for over 200 kilometers, I require nearly 180 lakh liters of diesel. On one hand, material non-availability. On the other hand, I have to transport the materials to a longer distances. Again, it is not sustainable. So the question before us, before you, when you graduate will be, how do I construct a pavement which will result in the lowest life cycle cost, at the same time will also reduce less quantity of materials, not only for initial construction, but design life of 30 years. So you look at this, we have to introduce new materials. When I want to introduce new materials in the design, how do I introduce these materials which will improve the performance, reduce the thickness of the pavement and reduce the cost is something that we have to talk about. So one way of reducing the aggregate consumption can be, you can introduce cement. What I am talking about is that if the subgrade is weak, as I was mentioning, CBR of the subgrade is 2%, 3%. Can I improve the strength of subgrade soil? Yes, you can do that. I can add cement to the soil. I can add lime to the soil. I am trying to modify the properties of soil, reduce the plasticity, improve the less moisture-induced damages. So if I can improve the strength of the subgrade soil by stabilization, then I can use cement. So that is called as soil cement layers. So now, earlier what we were talking is that this is the strength of subgrade, what should be the thickness of the pavement. Now, I can tell you what strength do you need, 5, 10, 15, 20, I can give. I can try to modify the soil. Now, these soils are called as engineered soils. You can get whatever strength that you need. So I can use a soil cement. So if the cement content becomes more, I can also use a roller to compact the pavement. That is called as a roller compacted concrete. If the water content is more and if the cement content is low, it cannot form a wearing course. Under repeated applications of abrasion, the concrete pavement, so-called concrete pavement, will abrade. So we need to provide a bituminous layer above that. On the other hand, if the cement content is more and the water content is also more, it is a conventional concrete pavement. If, as I was mentioning, about 77 centimeter thick bituminous layer, on the other hand, if I have a concrete pavement, the thickness of concrete pavement can reduce to as low as 300 millimeters. I can have a hard shoulder or a concrete shoulder and I can reduce the thickness even to 270 millimeters. From 770, I can bring down the thickness to less than 500 millimeter by having a concrete pavement. So one way of constructing sustainable concrete pavement is by reducing the thickness, by stabilizing the payment layers, or by having improved materials in the lower layers. Alternatively, I can also go in for an inverted payment. So, this is a third type of payment that we have started adopting in the country today. What I am trying to do as an inverted payment is that in a conventional payment, when we talk as a bituminous payment, I have a bituminous layer, a granular layer, a subgrade soil. The strength of the granular layer will be more than that of the soil. The strength of bituminous layer will be more than that of the granular layer. So, the strength will increase as you go from bottom to top. Whereas, in the case of an inverted payment, above the blacktop, I introduce a cement treated layer. When I introduce a cement treated layer, the thickness of bituminous layer can be drastically brought down. The aggregate consumption can be drastically brought down. From 200 millimeter, 170 millimeter, I can bring down to 50 millimeter to 75 millimeter. Out of the 54 lakh kilometers or 5.4 million kilometers of roads in the country, less than 1,20,000 kilometers are national highways. Majority of the roads do not require such thick bituminous payments. I can go in for an inverted payment with a cement treated base. I can introduce a granular base and a blacktop, and I can reduce the thickness drastically to, for example, 350 millimeters. So, this is the alternative that we have started adopting in the country today. Most of the payment that we are constructing today have got a cement treated base. The recent one is the Amaravati city being constructed. The entire network of roads that are being constructed in Amaravati will have a cement treated base. So, that will be long lasting, sustainable with a thin bituminous layers. So, the payment conventionally can be a bituminous payment, can be a concrete payment, can be an inverted payment. So, there are three choices. So, you have to now decide what payment type will last longer. Depending upon the material availability, depending upon the traffic, climate, environmental factors, you have to design the thickness of the payment. Now, as I was mentioning, most of the roads projects that are taken up are under the category of build, operate and transfer. The concessionaire invests money and constructs the payment. So, he would like to know which is the payment type that he should select that will result in the longer life. So, as a civil engineer, you have to recommend to him this for this traffic, for this subgrade soil type, for this climatic condition, this is the payment type. You should be able to predict the performance and then tell that this type of payment will result in the lowest life cycle cost. Many expressways are being taken up in the country today. Many airports are being renovated, rehabilitated, newly constructed. For example, a taxiway, a runway, should it be flexible? Should it be concrete? Should it be composite? Again, only a civil engineer can tell what is the payment type that will result in the lowest life cycle cost. So, having seen about this inverter payment, we have to introduce soil stabilization. So, now there are many materials available to stabilize the subgrade soil. What I am trying to do is, you have to find out what is the property of the subgrade soil which is available at the site. Find out the missing properties or lacking properties. It may be the swelling may be more, fines may be more. So, if you find that the property, lacking property, I can try to modify the properties by having chemical stabilizers. Many stabilizers are available in the market today. I can get whatever strength that you need. So, you can design the stabilized soil mix. So, again, the job of a civil engineer is to design a stabilized mix, find its properties, use that material property to design the thickness of the layers, predict the performance and then work out the life cycle cost. That is a challenge before you. When you are spending nearly 5 crores to 10 crores to 15 crores, whether it is a single lane or a 2 lane or a 4 lane, you have to be careful in selecting the type of the payment. Wrong choice of payment will result in a higher maintenance cost. So, soil stabilization is one method that we have started adopting across the country today in many of the national highway projects and rural roads. If you look here, I can also use industrial waste. Again, this job of civil engineer is to make use of this industrial waste in construction. Huge quantity of material can be used in road construction. For example, the outer ring road which I talked about for Chennai, we use more than 1 lakh cubic meter of fly ash. So, this is one for an embankment in Nizamuddin bridge at Delhi. The length of the bridge embankment is around 1.8 kilometers. Height varies from 6 to 9 meters. We have used nearly 1.5 lakh metric tons cubic meter of fly ash here. The fly ash by itself will not have cohesion, So, it has to be confined to soil layers there, but the point here is that you can use industrial waste in road construction, and that way you can preserve the environment. We can use the material in road construction. When material is not available, fly ash can be used for road construction. We can also try to use stabilization using lime. These are some roads constructed in Orissa, where subgrade is weak, it has got more swelling. You can try to modify the subgrade soil by using lime. That is, the road is finished, so this road will last longer. So, you can use either industrial waste, or you can try to stabilize the subgrade soil using cement, using lime, using fly ash. You can also do a double cement stabilization, lime and cement. Lime, cement, fly ash. Any of the combinations can be tried to improve the properties of subgrade soil. Alternatively, you can also use high performance bitumen. Normally, we use bitumen in the top layers. It's called as asphalt in America. It's called bitumen in British. Since we follow British terminology, we call it as bitumen. So, this bitumen, when used in a top layer, it has to withstand a high resistance to deformation, and a repeated application of loads. It should not rut. It should not crack. So, can I modify the binder that is used in the top layer? Yes, you can use that. There are a number of modified binders for high performance bitumen that are available, which will ensure better bonding between the aggregates and the binder. They will have higher fatigue life under repeated application of the loads. They will not crack, they will not rut. So, we can use a high performance bitumen. When it is exposed to atmosphere, it will not undergo aging, cracking. So, it will have an improved performance, but again all comes with cost. If you want a better performance, longer life, less distresses, spend more. So, you can use a high performance bitumen like this. It can take up repeated application loads without any failure. So, again the challenge before you is that what type of modification needed for the bitumen, what will be the increased cost, what will be the performance of this high performance bitumen. As you know, the cost of bitumen will be around 30,000 rupees to 35,000 rupees per metric ton. When I try to modify the binder, the cost will go up to 40,000 to 45,000 to 50,000 rupees. So, should I spend more money? Yes, it can perform better. But again, you have to find out there are different types of modified binders. Which one to select is again the recommendation, based on the recommendation of the civil engineer. Again, we have got better materials. I think it's time that we use new materials. One new material that can be used can be geotextiles. I think after recent last year floods, many of the roads in Kerala were cut off because of landslide. So, what should I do now? These geotextiles can be used for embankment with the steep slopes to ensure a better slope stability. You can have also geosynthetic layers in the pavements. You can also use them as a separation layer. For example, these materials are available in the form of a grid or in the form of fabric. You can use them as a separation layer. This will prevent entry of water saturating the upper layers. So, it is time that as a civil engineer, you use these materials in road construction. I will take you forward as how they can be better utilized in road construction. So, they can be used for slope stability and slope stability. They can be used as a soil separation layer that will prevent the entry of fines from subgrade to the upper layers. They can also be used in the case of runway pavements and taxiways. For example, if you are going to construct a runway and a taxiway in a soil which is weak. If the soil is weak, if you construct a runway and a taxiway, and because of the repeated application loads, the pavement will deform. That will result in early failure and unsafe for the passengers. The question is that how do I improve the strength of subgrade soil? So, when I have got a weak soil which has to be strengthened, what I can try to do is that I can try to reinforce this by introducing geogrids into that. So, the strength of the layer improves significantly. So, the question now is that what is the strength of this soil without any reinforcement? What is the type of reinforcement that I should choose? There are different types of reinforcement. It can be geofabric like this, it can be like this, it can be different types like this. So, what is the type that I have to choose? The next question is that in a given pavement layer system, where should I keep this? At 1/3 from bottom, mid depth, where should I keep? And what will be the improved strength of this layer system with the geogrid? So, this again has to be done only by a civil engineer. So, everything costs money, if you introduce a new material, that's an improved performance at what cost? So I can improve the strength of the subgrade soil by introducing geogrids here. So you can find the 2 layers of geogrids laid there. The runway or a taxiway can last longer without a deformation. No rutting, no cracking will occur. Alternatively, there are new other materials that are coming. For example, if the surface subgrade is weak, a truck cannot run on that. Alternatively, if I introduce a geogrid into the layer, the subgrade gets more support, a truck can move. So that's another application of the geosynthetics. The third application which I have seen is that you can use geocells. So these are geocells which can be used for construction of the pavement layers. So in a pavement, as I was mentioning, the load gets distributed over a wider area. So if I can fill these layers with aggregates, there's a confinement in between the layers. There's a possibility of water draining off from here, so the layer can support the load better. The stresses coming at the bottom will be much lower and the performance will be improved. Thirdly, because there's a confinement here, the thickness of the pavement can be drastically reduced. We tried this. This is again at a location in Maharashtra. We use a geocells for construction of a road. What we did was that we laid these geocell layers, filled that with aggregates, and then roll with a conventional roller. What are the advantages of having these geocells in road construction? The use of geocell is that, for example, if I require about 975 millimeter thickness of a pavement for a load, which has got a strength of 2% CBR, I can bring down the thickness from 975 to 520, from 975 to 520 millimeter by introducing geocells both at the base course as well as subgrade soil. So you have to now decide and recommend where this can be utilized, what will be the reduction in the thickness of the pavement layers, what is the cost. If you look at the cost again, the cost will be around 2,450 rupees per square meter, whereas conventional pavement is 2,635. This cost is not the issue. The issue is that availability of material for construction. So I can drastically reduce the thickness of the pavement layers, improve the performance, and you can see that the performance of pavement is around 20 years to 16 years in the conventional pavement. So improved life, lesser aggregate consumption, lower cost, and so it is time that you as a civil engineer, when you graduate, apply such new materials in road construction. So again, another thing which I have want to introduce is that you can try to have a concrete pavement. As you know, the concrete pavement, you should cure it for 28 days. You can open the road to traffic only at the end of 28 days. Now, those of you from Bangalore will know, number of roads have been taken up under as a white topping, a concrete overlay over a bituminous pavement. So I can construct around 300 meters, 400 meters per day. If I have to have around 200 kilometers, 300 kilometers of roads, it takes number of days to construct these roads. Alternatively, it's time that we look at precast concrete pavements. Can I fabricate these concrete pavements elsewhere, bring it to a site? I can make fabricate slabs like this, bring it to a site, assemble them, and then open the door to traffic. You can do a post tensioning after you fabricate all these, arrange them in the section and do this. We have started this, adopting this for the first time in the country for the outer ring road at Nagpur. A research work is being under progress in IIT Nagpur today. So concrete pavements, I think it's time that some of you can become an entrepreneur, can have a company for a precast concrete pavement. You'll find that this technology will be adopted wherever you want to have a faster construction. The road should not be there today. Tomorrow morning when you come, a concrete pavement should be available. So that is a challenge that is before you. So concrete pavements can be brought in, assembled at the site, and then open the road to traffic. So these are some technologies that we have to now adopt. Now, having talked about this construction, bituminous pavement, concrete pavement, composite pavement, use of new materials in terms of binder, geosynthetics, stabilizers, precast concrete pavement. So we have created the infrastructure today, or we are creating the infrastructure today. The challenge before you is that how do I maintain this infrastructure? That is going to be a huge task before you. Many of the projects, as I was mentioning yesterday, many of the projects, road projects, are available for sale. These projects come under the category of what is called as the TOT, toll, operate and transfer. The road constructed road is available for sale. You can buy the road, road project for the project road 60 kilometers, 100 kilometers, 200 kilometers. But you have to toll the road, you have to operate and maintain the road, and then you can transfer at the end of 30 years. Which means you have to evaluate the condition of the road and find out what is the lacking performance requirements. So when the road is constructed, every road, any road that you construct for that matter will deteriorate. So more the road you construct, when you do not maintain the road will develop potholes. But I cannot compare the pothole to other countries with India because there are big craters. So when these potholes form, I think this one is a issue of maintenance, other is the issue of safety, beaten, battered, bruised. So why the roads deteriorate like this? Is the problem with the design? What has gone wrong? Remember, the major problem is because of water. It's not that we are walking on the moon, we are walking on the roads. Potholes are there. It has become a shame. You go to Bangalore, every year they'll count the potholes. They'll say that today I counted 10,000 potholes. Today I counted 20,000 potholes. It's a shame that civil engineers are not able to construct a long-lasting, durable road effect. We can go to moon and Mars, but we do not know how to construct the roads. So that's the challenge before us, what has gone wrong. So when you look at these roads that are being constructed, the enemy is water. For a civil engineer, water is enemy number 1, enemy number 2, and enemy number 3. So if you do not care water, at the time of construction, the water will remain there. I am here. You never cared me at the construction, I am here. So the issue is that how do you take care of this? One way of solving this problem is having a void topping. On a given bituminous pavement, which I was talking about earlier, on this bituminous pavement which has become deteriorated, I can provide a concrete overlay on the top. So majority of the problem of water induced damage can be reduced. I can also mill this layer, reduce the thickness and put a concrete layer on this. So one of the major problems that we are facing in urban location is that the road was at a higher level, lower level, house was constructed at a higher level. Today the road level has gone up, houses remain the same level, and all the water from the road comes to the houses, and then that's why flooding occurs in majority of the locations in Chennai. So if I can construct a void topping wherein I mill a part of the bituminous layer and construct a concrete pavement above that, that can last longer. So Bangalore, they have realized the importance of void topping. Several 100 kilometers of roads in Bangalore are being void topped. They are trying to do that in many other locations in the city. Even in Chennai, we have done some locations where the void topping. So again, this thickness of void topping can vary from 100 millimeter to 250 millimeters or 220 millimeters. So if the thickness of bituminous layer, if I have a layer above this, the layer is very thin, then that is called as ultra thin void topping. If I provide a thin layer on the top, then it's possible that the layer may crack. So I have to ensure a bond between this concrete pavement and this bituminous layer. So how do you ensure the bond between these layers is the question here. So I have to mill the surface to ensure a better bonding and provide a concrete pavement. At this point of time, there are 3 types of void topping. One is thin void topping, where thickness varies from 100 millimeter to 200 millimeter. Ultra thin void topping, which is less than 100 millimeters. So here again, if you want to have thin layers, you have to ensure a bond between the bituminous layer. So here again, as the thickness becomes less, the size of the panel also becomes less. For as can be seen here, the size of the panel will be around 1.8 meters by 1.8 meters, or 1 meter by 1 meter. Thinner the pavement, smaller the slab size. But if you can have this, if you those are from Bangalore will know, the Nandi highway, the outer a part of the peripheral road of Bangalore is constructed with void topping. The thickness of the void topping is only 180 millimeter, but it has been lasting last 5 years without any major maintenance. So sustainable, long-lasting pavement, one possibility is having void topping over a bituminous pavement. Again, it provides a removal of the rutting, so I can mill the surface. Now milling machines are available. I can mill the surface which will ensure a better bonding. This is how a milled surface will look like. On this milled surface, you can have a void topping, a concrete pavement. But you have to cut this to a size to 1/3 depth using milling machines, cutting machines. So more cutting machines are required if the slab size is very small. So you can have void topping on a deteriorated bituminous pavement and forget about the road for 20 to 30 years. So bituminous pavement can also be made sustainable by constructing concrete pavement. The other issue that you have to face is that all the roads will deteriorate. When there are different types of vehicles on the highway, cars, two-wheelers, auto rickshaws, trucks, buses, the majority of the distress on a pavement is only from the concrete pavements. Sorry, from the commercial vehicles. So, more the commercial vehicles, faster the deterioration if you are not accounted in the design. So, one factor is the heavy commercial vehicle which causes the deterioration of the pavement. Second is environmental factors. Water will get into the layers. Thirdly, this surface when it is exposed to atmosphere, there will be oxidation of the binder, loss of volatile matter, the top bituminous layer will become more rigid, stiff and may crack. Once it cracks, water will enter into the pavement system. Once the water enters into the pavement system, it strips the binder from the aggregates and potholes form. So, second reason is the environmental factors. Third is inadequacy in the design. The loss can be about the lack of support, subgrade getting weak because of moisture induced damages. So, if that is the case, how do I design the pavement? As the pavement starts deteriorating, a pavement is very good initially, it will be excellent initially. So, this will start deteriorating with the passage of traffic. So, if I do the maintenance here, it is called as a preventive maintenance. More and more I delay the maintenance, the cost of maintenance will go up. If the thickness of bituminous layer required maybe around 20 millimeters here, the thickness of the layer will be 200 millimeters here. Number one, I am increasing the cost of maintenance by delaying. Number two, I am increasing the thickness of bituminous layer by delaying. Number three, I am requiring more material for maintenance if I delay. So, a stitch in time will save 9. So, this is how a pavement deterioration takes place, and if you do early, the cost of maintenance will be maybe 1 rupee, more and more a delay, the cost will go up for 4 to 5 rupees. Other is that how long we can do an overlay over overlay over overlay. It's time that we have to should relook as how do we construct a sustainable pavement. One way of having sustainable road is, for example, this is a hillock near Bangalore, where every time when I come to the airport, I just take a photograph. It was a full hillock, become half, and now for a period of time, the hill will last. We have to look at that for your grandchildren, perhaps. If you have to show a hill, you have to show only on a paper, a hill will look like that, because we have to use all the hill material for road construction. That is not sustainable. So, what should we do now? The option before us to use is that this is a case of a Chennai Tada road. We can find the road has deteriorated with full of cracks. Many roads, because of the repeated application of loads, develop cracks. The cracks may be only the top. The fatigue cracks occur from the bottom, but this is a top down crack because of aging, because of increased loads, overloading, because of increased tire pressure. What I can try to do is, because of the crack, I need not provide an overlay over this. I can mill the layer up to the depth to which crack has propagated, reuse the material. In a nutshell, sustainability talks about reduce, reuse and recycle. It's time that you adopt recycling technologies in road construction. So, if you look at this, I can mill the entire material. Now, milling machines are available. If the road has deteriorated, I need not provide an overlay about that. You mill the material, use the material again and again and again. So, milling is the first step when you want to reuse the materials. Once you mill the material, I can do a coal recycling. In the case of coal recycling, I mill a part of the bituminous layer. I use a reclaimed material. I can use a foam bitumen. What is the foam bitumen here? So, I can do a coal milling here. I can try to inject a hot bitumen, water on one side, air on the other side. So, the volume of bitumen increases by 14 to 17 times. This will try to spot well the milled particles. I can use that material in road construction. I can mill the material. I inject the foam bitumen. So, this layer is called as a bitumen stabilized material, or called as a BSM. So, I have not thrown out the whole deteriorated pavement material, I am trying to reuse it again. Because the material has deteriorated, I am trying to strengthen the material properties by using a foam bitumen. I can reduce the thickness of the layers. In the case of coal recycling, this is how the material look like. I can use that as one of the excellent binder coats. I can reduce the thickness of the bituminous layers. What I try to do here is that Okay. What I try to do is I had to add cement to the layer to increase the stiffness. I mill the material. I have got a tanker of bitumen. I have a tanker of water. I try to mill the material. To the milled material, I use the foam bitumen and lay it and compact. So this will result in reuse of the material, stiffening of the aged materials. I try to rejuvenate the oxidized aged bitumen, and by the process, I can reduce the thickness of the bituminous layers. So this is one way of reusing the material, and this technology we have started adopting in several highway projects in the country today. The other way by which we can do this is a hot in-place recycling. So what we are now, second technology that we are adopting today is that I can try when the surface has got corrugations, bleeding, minor cracking, low friction, low rutting, I try to heat the layers. So this is a process that we are adopting today. I can heat the layers, I can scarify the material. Once I try to scarify the material, you have a pug mill where I bring in virgin material, aggregates, mix the material and lay it back. So with the result, the finished road surface will be approximately similar to that of the old deteriorated pavement. I am reusing the material. With the result, the requirement of virgin aggregate will be marginally very, very less. So the technology that has to be adopted in the years to come are, number one, you have to reduce the construction either by stabilizing the subgrade, using geocells, geogrids, geosynthetics, use modified binders, or in the case of recycling, adopt a case of white topping, or recycle the material, either hot recycling or a cold recycling. Any of the technologies can be adopted. So all these choices again depends upon the proficiency of the civil engineer who is in charge of the project. So you should not only be able to select the type of pavement, select the type of material, at the same time you should also be able to predict how it will perform, what will the maintenance requirement, how is the maintenance cost. So that is a challenge in a nutshell. Life cycle cost analysis, road asset management, pavement preservation. These are the technologies, techniques that you have to adopt when you graduate. So construction is one hand, the maintenance is on the other hand. Maintenance challenges are like a doctor diagnosing a disease. You have the road that is deteriorated, for example, campus roads. The campus roads are deteriorated. These roads were constructed in the year 2009. Now they are 10 years old. Now what should I do now? So as a civil engineer, you should be able to tell, should I recycle? Should I use a modified binder? Should I adopt a white topping? What type of binder to be adopted? Again, the choice depends upon the performance, and the performance depends upon the choice of material. Again, your proficiency in selecting and recommending the right material for the right pavement at the right time. The other issues are that runways and taxiways will be the challenge that you have to do it. There are several runway pavements that have to be rehabilitated, reconstructed. The challenge before you is that how do you do that? For example, the Airbus that has been constructed, city capacity is more. The challenge before you as a transport engineer is that the capacity of this is 555 in three classes or 853 passengers in one class. But the issue that you should see is that the maximum takeoff weight is 590 tons. Now you have to design a pavement, a runway and a taxiway such that it does not deform, crack, rut under this huge load. The empty weight is 252 tons, but the full takeoff weight is 590. The aircraft takeoff weight is more because of it is fuel is full. The landing weight is less. So the challenge before you is that how do I design a sustainable pavement for a load of 590 tons? So unlike a highway where the traffic wanders, in the case of a runway pavement, they follow a particular path. So wheel rutting will be along a particular path. In the duration of the load application, a runway is only a fraction of a second because the aircraft lands at 200 to 250 kilometers per hour speed. But it reduces speeds when it goes to exit taxiways and crawls at a low speed in a taxiway. So the deterioration in a taxiway will be more than the deterioration in a runway. So how do I design a sustainable taxiway? What material, what type of pavement, what are the combination of different layers is again a challenge. So this is not only this, supposing if I have 1000, assume that 853 passengers are to be carried by one aircraft. To see of these 850 passengers, at least 1500 people will come, visitors. So you need the terminal to be designed, For these 853 passengers, you have to now design that all the terminal facilities, starting from seating arrangements to security clearance to the all other facilities till boarding. So again, a job of civil engineer is not only designing the runway and the taxiway, but all the terminal facilities, including parking, access, all the facilities are to be designed by a civil engineer. This as far as the airport taxiways are concerned. The other challenge before you will be construction of roads in inhospitable and difficult terrain. For example, I want to have for roads for strategic importance. I want to construct the roads in Himalayas. How do I construct a concrete pavement? Can I construct a bituminous pavement? When the temperature is low, for example, I want to construct a road here. The temperature recorded is minimum minus 40 degrees centigrade. How do I construct a road there? What machinery can I take it there? Unless we form a road, it's a challenge before us, before the enemies. How do I protect the country? So how do I construct the road? What should be the pavement type? Should I recycle the material? Should I have a concrete pavement? Again, a challenge before us. So climate is more important. The window for you to work may be 3 months in a year. In the 3 months, you should construct the pavement. So here again, for example, this aerial view of the hard rock portion in a section of Himalayan region. You have to construct the road there. Because of the requirements of oxygen is less there, you will find it difficult for the working efficiency for these machines. So how do you construct? It's a challenge. Again, landslides will be there once you try to destroy the nature. So the other challenge before you as a civil engineer is that the value of time. In all highway projects, time is money. If a highway project delays by 1 year, the cost will go up by 25%. The cost of the material increases. You lose toll revenue. You have taken loan from banks and financial institutions. You have to repay with the principal and the interest. So time is money. So not only selection of material and the design of the payment, you should also be proficient in project management. How do I construct the facilities the quickest possible time? Can I adopt precast technology? How do you do, even for example, a flyover in a city, how do you do that? So a challenge before you is that project management, time management, and selection of appropriate type of materials and design so that we are able to complete the infrastructure in the quickest possible time. So there are several challenges before you as a civil engineer. To summarize all this, the Indian highways today, we are able to see highways comparable to any other country of the world. This is a Mumbai-Pune expressway we have. There are other highways which are comparable to any other developed country of the world. The recent one is the Yamuna expressway. One thing which I have not talked about is about the safety issues, because that I could not cover within these 2 hours of time. Nearly 150,000 people get killed on Indian roads every year. So better roads, higher speed, more accidents. So again, the challenge is how do you construct a sustainable and forgiving highways is the challenge before you. Even a driver wants to travel at 200 kilometers per hour, you should not be able to travel. How do you design the facility to meet that is a challenge. So challenge before you is the Yamuna expressway here. So I think more and more traffic in urban areas, you'll design more and more interchanges. So this will be a challenge before you. More the traffic, you are happy as a civil engineer because job opportunities are more, challenges are more, you have to design. It's not just single level. If you go to Velachery, we are going to see the 2-level flyovers. I think that will come in the years to come. More and more interchanges will be there. So you have to design these interchanges, again a challenge before you for different categories of vehicles. More congestions, this is a normal scenario. How to solve this? In a democratic country like that, Singapore is easy. You cannot buy a car unless you pay a hefty fees, licensing. But here, anybody can have a car. So including everyone is there in the same group. So again, by Delhi, 8-lane highways. You can make 20 lanes also, but 20 lanes will be congested like this. So challenge before you as a civil engineer is that how do I solve this problem of congestion, delay, and accidents is a challenge before you. More and more you construct, I think it's time. I think the time is not far away when you find railways which are like this. We need roads become bad, we need new facilities, new way of thinking as how to take the people above the bad roads. So this again a challenge, how to rehabilitate this road, what has gone wrong, how to repair the road. That becomes more and more challenges before you. I think time is not far away when we find roads in the countries like this. So this is going to be the future of Indian traffic in the years to come. Not only the highways, railways, airfield as well. So more and more problems. I am happy that there are more opportunities before you. So what you have learned is that we need a green highways materials are not available. So something that you have learned is that it's time that you talk about new materials in design and construction, how to conserve the materials by reducing, reusing and recycling the materials, how to design a long-lasting pavements, new technologies in construction like a precast construction, recycling the materials, try to construct green highways, improving the drainage of the facilities, urban pavement management, having void topping, how to manage the road asset is something that you have to face in the years to come. And the scope for highway engineers is that you have huge potential for as a highway planners, highway designers, construction of rural roads, urban roads, intercity highways, interchanges, border roads, construction using new materials, new technologies, maintaining the road asset that you have created, improved performance using new materials, and how do we manage this road asset is a challenge before you. I think there is no dearth for job for a civil engineer in the highway engineering profession. I am happy that you have chosen the profession, the branch either by compulsion or by choice. Doesn't matter. I feel that overall, if you look, I always tell in my class, you can always say that I was engineer for this building. I was engineer for this flyover, bridge, you can tell. Ask any computer science engineer, let him tell that this software is written by me. You can be proud that you are being a civil engineer. So and more than anything else, I personally feel that civil engineer can enjoy the life. He will have the money, he can enjoy the life. Overall, it's a win-win situation. So you need not repent for having chosen civil engineering as a profession. Definitely, over the period of time, you can enjoy the profession working like this in several challenging projects. So I wish you all the very best.